Determining even and odd functions. Some functions exhibit symmetry so that reflections result in the original graph. For example, horizontally reflecting the toolkit functions f of x is equal to x squared or f of x equals the absolute value of x will result in the original graph. We say that these types of graphs are symmetric about the y-axis. So symmetric about the y-axis, this is y. Let's take a look at that graph. Okay, if we have x squared, you can see if we put a line down here, it is symmetric according to the y-axis. If we take a look at the absolute value of x, again, if you cut a line or cut it in half, you can see that it's symmetric according to the y-axis. Now, we say that these types of graphs are symmetric again about the y-axis. Now, a function whose graph is symmetric about the y-axis is called an even function. So if you take a look at our graphs that we just graphed, it's a symmetric according to the y-axis, so therefore it's an even function. Now, a function, if the graphs of f of x equals x cubed or f of x equals 1 over x were reflected over both axes, then the result would be the original graph as shown in figure 17. So let's take a look at these graphs on Desmos. Okay, so if we take a look at x now cubed, what it's saying here is that if you rotate this, now if you rotated this graph here and then back, so if you rotated it around the origin, meaning the middle, right? If you rotated it and went and gone into a clockwise direction, what's going to happen is you're going to end up being in the same spot if you rotate it that way. So that means you're rotating it around the origin. Okay, if you take a look at the graph 1 over x, okay, if we rotate this graph around the origin, because the origin is what is creating this symmetry, if you rotate around the origin, it's considered an odd function. So let's take a look at f of x is equal to x cubed. So this is the function that we saw on Desmos. Okay, now if we reflect it according to negative x, and then apply the negative x to it, we're going to end up back in the same original space. So let's take a look at that again on Desmos. So if we have negative applied to the input and then raise that to the third power, okay, we can see what's happening now. So the original graph is in red, and now we can see it's reflected horizontally according to the y-axis. Now, if we take a negative value and then apply it to the negative x here, okay, we should end up in the same location once I apply that exponent of 3. So now you can see that now it's turned purple because the purple now has the same result as x cubed. So what we've done is we rotated it all the way around the origin. So the cubic tool function, again, had a horizontal reflection and then a vertical reflection. So we say that these graphs are symmetric about the origin. So a function with a graph that is symmetric about the origin is called an odd function. Now note, it's possible where a function can be neither even nor odd if it does not exhibit either of those two symmetries. For example, f of x equals 2 to the x power is neither even nor odd. And let's take a look at the reason why for that. So if we have 2 to the power of x, okay, we can't reflect this. When we reflect this, all right, let's just try this. So we have 2 to the power of negative x. Okay, now that reflects here, right? Now, if we apply the negative 2 to the power of negative x, well, now it's down here. So it did not do a full rotation, and it's not reflected around the y-axis. So even and odd functions. A function is called an even function if for every input x, f of x is equal to f of negative x. So the graph of an even function is symmetric about the y-axis. Now a function is called an odd function if for every input x, the negative f of x is equal to f of negative x. And the graph of an odd function is symmetric about the origin. So now we can apply this rule either to a graph, or we can also do this algebraically, which we're going to see in some of our next exercises.